Hi, welcome all to the online classes. I'm Mukesh Bhardwaj. Today going to represent the topic amplitude modulation, subject communication system, BTech electronics and communication fifth semester. So amplitude modulation, basically amplitude modulation may be defined as a system in which the maximum amplitude of the carrier wave is made proportional to the instantaneous value amplitude of the modulating or baseband signal. Let us consider a sinusoidal carrier wave Ct given as Ct is equals to A cos omega Ct omega c into t. Here A is the maximum amplitude and the carrier wave of the carrier wave. Now omega c is the carrier frequency. For simplicity, we have assumed that the phase of the carrier wave is zero in the equation which I had described you. Now let us take xt denotes the modulating or baseband or massive signal. Then according to the amplitude modulation, the maximum amplitude A of the carrier will have to be made proportional to the instantaneous amplitude of the modulating signal xt. So the standard equation for the amplitude modulation AM may be expressed as st is equals to A plus xt bracket close cos omega c t. So few points about amplitude modulation. So as whatever the equation I had describe the time domain behavior of the amplitude modulator signal. It may be noted that the carrier signal Ct is equals to A cos omega Ct is fixed frequency signal having frequency omega c. The modulating or baseband signal xt contains the information or intelligence to be transmitted in the process of amplitude modulation. This information is superimposed upon the carrier signal in the form of amplitude variations of the carrier signal. This means that the information to be transmitted is now contained in the amplitude variations of the carrier signal. In other words, in amplitude modulation, information is transmitted in the form of amplitude variations of the carrier signal. So, the resulting signal from the process of amplitude modulation is called amplitude modulated signal, or simply AM wave. In the process of amplitude modulation, the frequency and the phase of the carrier remains constant, whereas the maximum amplitude varies according to the instantaneous value of the information signal. So, amplitude modulation has a time varying amplitude called as an envelope of the amplitude wave. We will see in the next slides. So, this envelope consists of baseband signals, hence the modulating or baseband signal may be recovered from AM amplitude modulated by wave by detecting the envelope. So, amplitude modulation. The contents need to be covered. Introduction to the communication system we had already done. Analog modulation, the amplitude modulation, double sideband suppressed carrier, vestigial sideband suppressed, single sideband suppressed carrier, frequency modulated, pulse modulated, narrow band frequency modulated, phase locked loop demodulators, and phase log loops, sampling system, time and frequency division multiplexing system, Nyquist principle, pulse amplitude modulated, pulse position modulated, and pulse width modulation, principle of noise, random variables, white noise, short, thermal and flicker noise in cascade amplifiers, pulse code modulation, PCM and its derivative, quantizing noise and example, digital communication techniques, that is amplitude shift keying, phase shift keying, frequency shift keying, quadrature phase shift keying, QAM, quadrature amplitude modulation, and M array QAM. So these are the contents and the suggested readings or reference. Introduction to Analog and Digital Communication, Hyken, Simon Hyken, by the Wiley Publications, Communication System by Carlson, McGraw-Hill, and TMH, that is Information Transmission, Modulation and Noise by Schwartz, TMH, Analog and Digital Communication by Redin, Prettinson Hall, Communication System, again Hyken, Wiley. So these are some recommended or suggested readings or references. Introduction to modulation and demodulation. The purpose of communication system is to transfer information from source to destination. In practice, major problem arise in baseband transmission, the major cause being noise in the system. External noise and circuit noise reduce the signal to noise ratio at the receiver input and hence reduce the quality of the output. Such a system is not able to fully utilize the available bandwidth. For example, telephone quality speech has a bandwidth of 3 kHz. A coaxial cable has a bandwidth of hundreds of megahertz. Radio system operating at baseband frequencies are very difficult, not easy to network. Multiplexing is a modulation method which improves channel bandwidth utilization. For example, coaxial cable has a bandwidth of hundreds of megahertz. Baseband speech is only a few kilohertz. Frequency division multiplexing. This allows several messages to be translated from baseband where they are all in the same frequency band to adjacent but not overlapping parts of the spectrum. An example of FDM is broadcast radio, long wave, medium wave, etc., short wave, etc. Time division multiplexing is another form of multiplexing based on sampling, which is a modulation technique. In time division multiplexing, samples of several analog message symbols, each one sample in turn, are transmitted in sequence. That is, the sample occupy adjacent time slots. Networks, a baseband system which is essential point-to-point could be operated network. Some forms of access control multiplexing would be desirable, otherwise the performance would be limited. Analog communication networks have been in existence for a long time. For example, speech radio network for ambulance, fire brigade, police authorities, etc. For example, digital speech communication, in which the analog speech signal is converted to digital signal via an analog to digital converter, give a form more convenient for transmission and processing. What is modulation? In modulation, a massive signal which contains the information is used to control the parameters of carrier signals so as to impress the information onto the carrier. The message or modulating signal may be either analog, denoted by MT, digital, denoted by DT, that is sequence of ones and zeros. The message signal could also be multi-level signal rather than binary. This is not considered further at this stage. The carrier should be or could be a sine wave or a pulse train. If the message signal empty controls amplitude, gives amplitude modulation AM. If the message signal empty control frequency, give frequency modulation FM. If the message signal empty control phase, give phase modulation or phi m, PM or phi m. What is demodulation? Demodulation is the reverse process to modulation to recover the message signal, MT or DT at the receiver. Summary of modulation techniques, modulation types, amplitude modulation, frequency modulation, and pulse amplitude modulation. So this is the diagrammatic representation. Modulation types AM, FM, PM2. Again, this is the diagrammatic representation of frequency modulation. This is the modulation type. Again, the binary ASK, PSK, and FSK. Modulation type, again, the binary CPSK and FSK2. 4-level ASK, PSK, and FSK. Again, this is the diagrammatic representations of the modulation levels. Analog modulation, consider amplitude model, consider sine wave carrier. VCT equals to VC cos omega CT, peak amplitude VC, carrier frequency omega C, radians per second. Since omega C is equals to 2 pi FC, frequency FC equals to 1 by T. Amplitude modulation. In amplitude modulation, the modulating signal, the massive signal MT, is impressed onto the amplitude of the carrier. Massive signal MT. In general, MT will be band of signal, for example, speech or video signal. In notation or convention to show baseband signals for MT is shown below. In general, MT will be band limited. Consider, for example, speech via microphone. The envelope of the spectrum would be like demodulation of amplitude modulation. There are two main methods of demodulation. AM demodulation, that is envelope or non-coherent detection demodulation, synchronized and coherent demodulation. Envelope or non-coherent detection, an envelope detector for amplitude modulation is shown in the figure shown. That is the envelope detector or AM demodulator. This is obviously simple, low cost, but the AM input must be double sideband amplitude modulation with a modulation index very less than 1. That is, it does not demodulate DSB, DIMC, DSB, BSC, DSB, SC or SSB and double X. So this is the known coherent. Now modulation, the process of varying a carrier signal in order to use the signal to convey information. Carrier signal can transmit far away, but information cannot. So modem, amplitude, phase, and frequency. So modulation is a process by which is massive signal is superimposed on a carrier signal for transmission to a long distance. So according to the uh, carrier signal, we are going to modulate the original signal, and the modem that is based on the amplitude modulation, phase modulation or frequency modulation. In analog, amplitude AM, amplitude modulation, amplitude FM frequency, vestigial sideband modulation. Digital, mapping digital information to different constellations, frequency shift keying, QPSK, FSK, PSK. Channel coding, deliberately purpose and add redundancy to the transmitted information so that if the error occurs, the receiver can either detect or correct it. Source channel separation theorem, if the delay is not an issue, the source coder and channel coder can be designed separately. That is, the source coder tries to pack the information as hard as possible, and the channel coder tries to protect the packet information. Popular coder, linear block code, cyclic codes, convolution codes, LDPC codes, turbo code, zero point 0.1 decibel to channel capacity. Mean square quality of link, that is services or quality of services. Mean square error, the formulas to be used: signal to noise ratio, SNR, bit rate, bit error rate, frame error rate, packet drop rate, peak signal to noise ratio, SINR, SNIR, signal to noise pulse interference ratio, or human factor. So multiplexing is a simultaneous transmission of many signal through a single channel. So multiplexing, there are various type of multiplexing: time division multiplexing, frequency division multiplexing, code division multiplexing, space division multiplexing. So multiplexing is the simultaneous transmission of many signal through a single channel. Now we are just seeing in the diagram that is a red color line wirelessly is a channel, open air channel, and if so many signals are need to be transmitted from the transmitter side to the receiver sides, then we know that there is a range of transmitting the signal in a particular frequency. So only one user cannot have the right to transmit the signal from one end to another. Other also want to transmit in the same frequency range. So we just develop a technique of transmitting a signal from one end to another and by frequency division multiplexing, that time division multiplexing, or we can use code division multiplexing or CDMA, and the space division multiplexing. Communication networks, connection of two or more distinct, possibly dissimilar networks, require some kind of network device to facilitate the connection. And basically, routers, or we can say the switches are connected first, then to the routers, and there is a specific algorithm for that to route the data packets or the signal packets, and it's reached to the uh, in a very shortest time or in the shortest path. They choose according to the traffic density and channel capacity. Broadband communications, SONET, SDH designations and bandwidth. SONET optical carrier level OC1, OC3, OC12, OC24, and these are the some SONET optical carrier level designations. SONET frame format, these are the format related to the carrier level, and SDG level and frame format related to the carrier level. Payload bandwidth, kilobytes per second, line rate, kilobytes per second. So these are the various designations and bandwidths for broadband communication. OSI model, that is Open System Interconnect, ISO OSI model. Basically, it is the Indian Standard Organization, International Standard Organization Open System Interconnection, and that is in the networking. OSI model is very similar to the, because as we knew that we are transmit any signal or we are just doing anything electronic message transmission through the electronic mode, then there is some sort of protocols needed to be applied for transmitting the signals from one end to another. So, as an analogy of sending a mail, if I'm talking about a, suppose if you want to write a letter and you need to send your letter to your friend in the earlier time, what we need to do that first we write a letter in a proper format with proper syntax and semantics, and then we just cover that letter, put that letter in the envelope, then paste the envelope and put a stamp over it, and, then we went to the uh, red box and drop a letter over there, and the person or employee from the postal department comes and collect the letters from that red drop box, and just take all the letters to the GPO, General Post Office, or the Central Post Office system, or nearby the local post office. There, the assorting takes place according to the reason wise. There, we just get assorted and the letters according to the reason or according to the pin code wise. Then, the next protocol is just we are going to deliver the letters through various modes of or means, by road, by railway, by uh, water, by air. So it depends upon the reason also where we are going to send that letter. After that, these letters reach to the uh, general post office of that particular region, and again it is assorting according to the area wise, the local area wise, and then assorting of that letters done, then the individual area postmans take the letters and when to go for the dispatch to the end user. So there are protocols how you are going to be just transmit your message from one end to another end. Similarly, in the electronically system or the electronically, if you want to transmit the message or signal, for example, in the case of electronic mail or email, uh, first the OSI model set up protocols. and it is open system interconnection, international standard organization, in which the application layer, then the presentation layer, then the session layer, then transport layer, then network layer, then data link layer, then the physical layer. So at the level of that is, if I'm talking about the first four, and this is 7 layer protocol. So the first four layers are known as host layers, and the last 3 layers are known as the media layers. So at the application layer, data is to be processed and synthesized. Again, at the presentation, the data representation and encryption takes place in the application network process to application. And the third layer, that is session, inter-host communication of the data. And the fourth layer, that is transport, end-to-end connections and reliability is set. And then segments of the data takes place. And then network layer, the protocol of the network layer comes into the existence, that is part determination and logical addressing IP. Then the data just convert into segments, convert into packets, and after that these packets move in the form of frames through the data link layer, that is physical addressing MAC layer or LLC. And after that, that frames are converted into bits and transmitted through the physical layer, that is media, signal and binary transmission. So it is a very important open system interconnect. OSI model is a very important model in the reference model for electronic communication. And TCP/IP, Transmission Control Protocol, Internet Protocol Architecture, is the de facto global data communication standard. It has lean 3-layer protocol stack that can be mapped to 5 of the 7 in the OSI model. TCP/IP can be used with any type of network, even different types of networks within a single session. History of telecommunication, audio signals, prehistoric communication, drums, horns. This is the history of telecommunication, in which year what invent or what he had invented. Advanced electrical electronic signals. So it is important through the history point of view. Now, baseband and carrier communication. Baseband describes signals and systems whose range of frequency is measured from 0 to maximum bandwidth or highest signal frequency. Voice, telephone 0 to 3.5 kilohertz, CD 0 to 22.05 kilohertz, video analog, TV 4.5 megahertz, TV channel is 0.6 megahertz, digital depending on the size, movement frames per second. Example: wires, coaxial cables, optical fiber, PCM phones. Carrier communication, a waveform, usually sinusoidal, that is modulated to represent the information to be transmitted. This carrier wave is usually of much higher frequency than the modulating baseband signal. Modulation is the process of varying a carrier signal in order to use that signal to convey information. Example on the board, or in the next slide, we are just modulation, a process that causes a shift in the range of frequency of signal. What is gain advantages? Antenna size, half of the antenna size, thousands of miles for baseband. Better uses of limited bandwidth, less side loops, great bandwidth for SNR, CDMA, robust to inter-symbol interference, that is multi-part delay, robust to errors and distortions. Types: analog, amplitude modulation, double sideband, single sideband, vestigial sideband, and frequency modulation and phase modulation, then delta modulation. And the digital modulations are of the type ASK, frequency shift king, PSK phase shift king, quadrature amplitude modulation, And the pulse modulation is the pulse coded modulation, that is PCM, pulse digital modulation PDM, fiber phones, advanced type of modulation CDMA 3G, OFDM in W lane, and VMAN, that is orthogonal frequency division multiplexing. Double sideband modulation MT cos omega CT 0.5 m omega minus omega c plus m omega plus omega c. Lower upper sidebands, double sidebands suppress carrier, no carrier frequency. Uh, WC is greater than or equal to the bandwidth of the signal to avoid aliasing. The demodulation, the equations arises like this. Low pass filter to remove the higher frequency. Coherent and non-coherent detection. Receiver can recover the frequency and phase of the transmitter by phase lock loop PLL. Here, error of timing can cause the performance error floor. Non-coherent receiver has 3 dB worse performance than coherent. Cheaper for non-coherent receiver next. So these are the diagrammatic representation of the waveforms, single sideband, double sidebands, or amplitude modulated waves. Multiplier modulators multiply MT by cos omega CT, hard for linearity for high energy expensive. Examples, sound systems. Nonlinear modulators, examples. Switching modulators, FFT transformed to series of frequency. Series bridge diode modulator, shunt bridge diode modulator, ring modulator. Frequency conversion, move the signals to other frequency, multiplying two sinusoidal results. Multiplying two sinusoids results into two frequency, which are sum and difference of the frequency of the sinusoids multiplied. uh, Cos alpha t cos beta t is equals to 1 by 2 cos alpha minus beta t plus cos alpha minus beta t. To change the carrier frequency omega c of the modulated signal to an intermediate frequency omega, we use an oscillator to generate a sinusoid of frequency. Maxwell's that. So these are the some diagrammatic representation of the waves. Why double sidebands suppress carrier not working? Do not know the carrier frequency in receiver. The last impulse function indicate the carrier is not suppressed. In this case, for some shown the modulated signal spectrum is shown. Phi mt equals to a plus mt cos omega ct, and this is the equation of the amplitude modulation wave. Which this type of amplitude modulation, the demodulation can be performed uh, with or without local oscillators synchronized with the transmitter. Next, amplitude modulation example. MT has a minimum value of about 0.4. Adding a DC offset of A equals to 1 results in A plus MT being always positive. Therefore, the positive envelopes of it is just A plus MT. An envelope detector can be used to retrieve this. The choice of DC offset should be such that the choice of DC offset should be such that That A plus empty should be always be positive. Otherwise, the envelope detector cannot be used, but coherent is still okay. Modulation, therefore, modulation is the fundamental requirement of communication system. Modulation may be defined as process by which some characteristic of a signal known as carrier is varied according to the instantaneous value of another signal, known as modulating signal. The signals containing the intelligence or information to be transmitted are modulating signals. These modulating signals containing the information are also called baseband signals. Also, the carrier frequency is greater than the modulating frequency, and the signal which results from the process of modulation is known as modulated signal. Modulation may be classified as continuous wave modulation and pulse modulation. If the carrier waveform is continuous in nature, then the modulation process is also called the continuous wave modulation. The example of this type of modulations are amplitude modulations and angle modulation. On the other hand, if the carrier waveform is a pulse type waveform, the modulation process is also is called as pulse modulation. The examples which we had already discussed for this type of modulations are pulse amplitude modulation, pulse width modulation, pulse code modulations, etc. So amplitude modulation, angle modulations are two families of continuous wave modulation system. In amplitude modulation, the amplitude of a sinusoidal carrier wave is varied in accordance with the baseband signal. On the other hand, in angle modulation, the angle of the sinusoidal carrier wave is varied in accordance with the baseband signal. Amplitude modulation is discussed in this chapter or in the slides, and we had already discussed that about the multiplexing. I had already told you that simultaneous transmission of many signals through a single channel. So multiplexing is a technique in which several massive signals are combined into a composite signal for transmission over a common channel. In order to transmit a number of these signals over the same channels, signal must be kept apart so they do not interfere with each other, and hence they can separate it easily at the receiver end. So multiplexing is basically of two types under the frequency division and time division. And the third most, which we had already discussed, that the code division CDMA techniques also for the multiplexing. So we had discussed about the amplitude modulation. Amplitude modulation may be defined as a system in which the maximum amplitude of the carrier wave is made proportional to instantaneous value or amplitude of the modulating or baseband signal. Here the baseband signal means the massive signal. So for that, we know that the sinusoidal wave, carrier wave, the nature of the carrier wave is sinusoidal. So we know the equation of sinusoidal equations can be given as a CT or MT or is it CT. Here the carrier is talking the CT is equals to A cos omega CT. Here A is the maximum amplitude of the carrier wave and omega C is the carrier frequency. Now let denote the modulating baseband signal with xt. Then according to amplitude modulation, the maximum amplitude of A of the carrier will have to be made proportional to instantaneous amplitude modulated signal xt. So the standard equation for the amplitude modulation may be expressed as xt cos omega ct plus A cos omega ct. So st is equals to A plus xt cos omega ct. So according to the equation discussed, we are just seeing that modulating signal, baseband signal, carrier signal, or modulating signal. Next. So modulation index M, up to which extent we can modulate the signal is known as modulation index, and its value lies between 0 and 1. So modulation index is defined as let MP be the absolute negative peak of MT. A single tone modulation, let MT equal to 2 sine omega 2 sine 20t. So A is greater than or equal to MP. A is the carrier amplitude. Modulation index is given by mu equals to MP by A. Then we see that for A greater than or equal to MP, modulation index lies between 0 to 1. when mu is greater than 1 or modulation index is greater than 1, the signal is over modulated and envelope detection cannot be used. However, we can still use synchronized demodulation. Sideband and carrier powers. Again, the important terminology. The first term is a carrier and the second term is the sideband, which contains the signal itself. The total amplitude modulated signal power is sum of the carrier power and the sideband power. So carrier power is given by PC equals to A square by 2 and sideband power is equal to P square 1 by 2 PM, where PM is the power of MT, that is massive signal. Sideband power is the useful power. Now the efficiency, the output upon input. So neta is given as useful power upon the total power, and this come out to be PM upon A square plus PM. For example, let MT masses in B cos omega MT, omega MT. So MP equals to B, mu equals to B by A, or B equals to mu A. So PM, that is B square by 2, and B can be written as mu square A square by 2, or now neta, or that is efficiency, can be useful power upon total power. So mu square upon 2 plus mu square into 100, that come out to be 33% for mu equals to 1. Now AM generator, this is the amplitude modulation generator diagram, how the AM signals are generated. Coherent detector for demodulating double sideband suppressed carrier modulated wave. Amplitude modulated non-coherent detector, rectifier detector, synchronous envelope detector, and these are the some presentation or diagram shown. Now quadrature amplitude modulation, QAM. See the diagrammatic representation, how the signal is transmitted through the synchronized way, and how the block uh, diagram is showing that how it is actually converted and then transmitted. So amplitude modulated signal bandwidth, amplitude signal band is twice the bandwidth of the modulating signal. A 5 kilohertz signal requires a 10 kilohertz bandwidth for amplitude modulation transmission. If the carrier frequency is 1000 kilohertz, the amplitude modulation signal spectrum is in the frequency range of 995 kilohertz to 1005 kilohertz. Quadrature amplitude modulation is a scheme that allows two signals to be transmitted over the same frequency range. The coherent in frequency and phase is expansive. TV for analog. Most modems work on the uh, quadrature amplitude modulation system. Now, sideband, single sideband proposed to reduce the bandwidth requirement of amplitude modulation by 1/2. This is achieved by transmitting only the upper sideband or the lower sideband of the double sideband amplitude massive signal. Because the upper sideband or the lower sideband contains the same information. So, to reduce the bandwidth requirement, we try to transmit only the upper sideband or the lower sideband. This is the diagrammatic representation, the how the signal is transmitted. The oscillator which generates the carrier frequency and the audio signal just through the balanced modulated band pass filter, then gives single sideband, and the single sideband signals are having uh, lower sideband and the upper sidebands, and they are need to transmit. Baseband, DSB, double sideband, and double sided and single sideband suppress carriers. Now SSB generator. Single sideband generator selective filtering using the filter with sharp cutoff characteristics. Uh, Sharp cutoff filters are difficult to design. The audio signal spectrum has no DC component. Therefore, the spectrum of modulated audio signals has null around the carrier frequency. This means a less than perfect filter can do a reasonably good job of filtering the DSB to produce the single sideband signal. Baseband signal must be bandpass. Filter design challenges. Uh, Next, SSB generator block diagram, phase shift method using Hilbert transformer, non-causal filter approximation. SSB demodulation, this is the demodulation site. Single sideband versus amplitude modulation. Since the carrier is not transmit, therefore is reduction by 67% of the transmitted power. In amplitude mode, 100% modulation, 2 by 3 of the power is comprised of the carrier, with the remaining 1 by 3 power in the both sideband. Because in single sideband only one sideband is transmitted, there is a further reduction by 50% transmitted power. Finally, because one sideband is received, the receiver needed bandwidth is reduced by one half, thus effective reducing the required power by the transmitter another 50%. Vestigial sideband is VSB is compromised between DSB and SSB. To produce SSB signal from DSB signal, ideal filter should be used to split the spectrum in the middle so that the bandwidth of the bandpass signal is reduced by one half. In vestigial sideband system, one sideband and the vestige of the other sideband are transmitted together. The resulting signal has a bandwidth, the bandwidth of the modulating baseband signal, but less than the double sideband single bandwidth. Filtering scheme for the generation of VSB modulated wave. This is the block diagram representation for the filtering scheme. This is the mathematic equation and the block diagram for the VSB transmitter, transceiver. Other facts about the VSB: comparison, common types and amplitude signal. These are the tabular chart for the comparison of amplitude, modulation, double sideband, quadrature amplitude, single sideband, vestigial sideband. Types of wave, as we know that waves are of depending upon of various range. In the ionosphere, long wave, space wave, TV phone, sky wave, short wave, ground wave, and how the communication takes place. These are the some radio frequency bands which we already know that extremely low, infra low, very low, low, medium, high, very high, super high, extremely high, tremendously high. These are the characters where they are going to be used: ground wave, ground sky wave, space waves. Satellite communication. So we will take this satellite communication in the next lecture. Satellite orbits, geostationary orbit, Geo, MEO, and LEO are the three stationary orbits, and depending upon the kilometer range. Geostationary orbit is near about 35,786 kilometer, and medium Earth orbit, that is situated at the 27,878 kilometer, and LEO is the lower Earth orbit, that is near about 347 miles away. International Space Station LEO, 249 miles. Now, thank you. That is all about the Analog communication. Thank you.